All right. So what is matrices? Matrices are a rectangular array of numbers. Rectangular array. Matrices is a rectangular array of numbers rectangular array of numbers within square brackets. Matrices is a rectangular array of numbers within square brackets. Got it? Rectangular array of numbers within square brackets. So this is like this. Say A, B, C, P, Q, R. This is a matrix. Sometimes in very standard books, you will see that matrix is also represented like in these kind of brackets. But mostly in Indian books and Indian system, we follow these square brackets. All right. So the standard appearance for a matrix A is A11, A12, A13, and so on A1n. Then this is AM1, sorry, A21, A22, A33, A23, A2n. Then it is A31, A32, A33, and so on, A3n. And in this way, it is AM1, AM2, AM3, and so on, AMN. All right. So this is what we call matrix of order M cross N. What it is? Matrix of order M cross N. Am I clear? So say if a matrix is like this, it is A11, A12, A13, A21, A22, A23, A31, A32, A33. Like we have this matrix. This is what row 1. This row to which I am highlighting, it is row 1. This is what we call row 2. And this is what we call row 3. Now, this is column 1. This is column 2. And this is column 3. Am I clear? So, column 1, column 2, and column 3. And this is what we call matrix of order 3 by 3. Sometimes we also write it like that is A is Aij. A is Aij 3 into 3. So that is also sufficient to write. Aij means what? Element of ith row and jth column. So Aij is what? Element of ith row and jth column. Understood? Like if a simple question I ask you, a matrix is having 36 elements. A matrix is having 36 elements. How many different types of matrices are possible? Types means what they are trying to discuss is how many different orders of matrices are possible. Like one is, if I say 1 into 36. Yes or no? This will be a matrix having one row. Nahi, Pujita, not correct. 1 into 36 means matrix having one row and 36 columns. Now there comes 2 into 18. Matrix having two rows and 18 columns. Then there will be 3 into 12. 3 rows, 12 columns. Then there will be 4 into 9. 4 rows, 9 columns. Then there will be 6 into 6. This is square matrix. 6 rows, 6 columns. Then there will be 9 into 4. See, this is, and these, they are different. One is 4 by 9 means 4 rows, 9 columns. Other is 9 by 4 means 9 rows, 4 columns. Then there is 12 into 3. Then there is 18 into 2. And then there is 36 into 1. Am I clear? So in this way, 9 different orders of matrices are possible if they are having 36 entries. All right. Anybody having any doubt up to this point? Arshini, Vinay? Any doubt? Now, let's come to some type of matrices. So first of all, there comes row matrix. Row matrix is what? Simple as the name suggests, that matrix having only one row. Like it is A11, A12, A13 and so on, A1n. So order is 1 into n. Having only one row, but 1, 2, 3, 4, up to n columns. Sometimes we also call it row vector. Now there comes column matrix. Now, what is column matrix? Matrix of this type. A11, A12 and so on, AM1. A11, A21 and so on, AM1. Matrix of order M is to 1. So having only one column. Fine. Then there comes horizontal matrix. Horizontal matrix. Horizontal matrix means like this kind of A, B, C, D, P, Q, R, S. This is a horizontal matrix. So matrix having 1, 2 rows, means number of rows is less than number of columns. Number of rows is less than number of columns. Then there comes vertical matrix. Like this kind of A, B, C, D, E, F. Now what it is? Number of rows is more than number of columns. Number of rows is more than number of columns. Then there comes the most important part is square matrix. Square matrix. So as the name suggests, number of rows is equal to number of columns. For example, say there is a matrix A11, A12, A21, A22. So this is what? Matrix of order 2 by 2. Am I clear? Matrix of order matrix of order, square matrix of order 2. See, sometimes while we are writing for a square matrix, so it is not necessary that I should say it is of order 2 by 2. Square matrix of order 2 automatically means it is having 4 elements of order 2 by 2. Now, if there is a square matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Now see what are the different terminologies here. First is A11, A22 and A33 are called diagonal entries. A11, A22 and A33, they are called diagonal entries. All right. And second, sum of diagonal entries that is called trace of matrix A. That means if this is what we write it, TR of A. So trace of A is what? A11 plus A22 plus A33. Agreed? Now the third term, Aij, where I is not equal to j, means A12, A13, A23, A32, all these entries, they are, we call off diagonal entries. Off diagonal entries. The fourth point is Aij and Aji are called conjugate entries. Like A12 and A21, they are called conjugate entries. A13, A31, they are called conjugate entries. This conjugate has nothing to do with the conjugate we have done in complex numbers. All right. So they are called conjugate entries. So these are basic terminologies about a square matrix. Now, what kind of square matrix do we have? Square matrix. So one we study is triangular matrix. Triangular matrix, and other we see diagonal matrix. Now in triangular matrix, further we see upper triangular matrix, and lower triangular matrix. In diagonal matrix, we see upper triangular matrix and lower triangular matrix. So what is upper triangular matrix? In upper triangular matrix, all entries below the leading diagonal are necessarily zero. Again, I repeat, in upper triangular matrix, all entries below the leading diagonal are zero. Means Aij is zero if I is greater than j, like A21, 2 is greater than 1, A31, 3 is greater than 1, A32, 3 is greater than 1. So all these entries are going to be 0. In lower triangular matrix, what happens? All entries above the leading diagonal are 0. Means here Aij is 0 if I is less than j. Aij is 0 if I is less than j. Am I correct? Now there comes diagonal matrix. Now diagonal matrix mean if it is D1, D2, D3, rest all are 0. D1, D2, D3. That is diagonal D1, D2, D3. Sometimes diagonal matrix we also express like this. So all of diagonal entries are 0 and all the diagonal entries, out of all the diagonal entries, at least one is non-zero. Am I clear? Anybody having any doubt up to now? Yes. Anybody? Fine. Very good. Thank you, Abhishek. Now, in diagonal matrix, we study scalar matrix. Now, what is scalar matrix? Scalar matrix is diagonal matrix, where D1 equals to D2 equals to D3 equals to A. So scalar matrix look like A0, 0, 0, A0, 0, 0, A. Like this. Means all the diagonal entries are same. Then there comes unit matrix. Unit matrix is when all diagonal entries in a scalar matrix are 1. So that is 1, 0, 0, 0, 1, 0, 0, 0, 1. See, at any point of time, if you feel like I am like running very fast, just ask me to put a hold. All right, so that you can complete your notes and understand and digest everything. So what is a unit matrix? This, it is expressed as I3 or I3 by 3. Identity matrix is like 1 in algebra. 1 multiplied to anything does not change it. Similarly, identity matrix is there. All right. Then finally, one last matrix there comes, null matrix. What it is? Null matrix. Harshini? Harshini, am I audible to you? Prem, can you hear me? Prem, are you able to understand everything? So what is null matrix? Null matrix is like all entries 0. Like this is O. O is here as null matrix of order 2 by 3. Null matrix of order 2 by 3. Fair enough? Yeah, unit matrix is also same as identity matrix. Unit matrix is basically identity matrix. Thank you, but I forgot to mention, which is important point. Sir, null or void both are same. Yes, yes, Nagaraj. Null and void matrix both are same. But like identity matrix is a popular term as compared to unit one. Similarly, null matrix is a popular term as compared to void matrix. Fine. Now there comes a term, equality of matrices. So how come two matrices be equal? All right. How come two matrix be equal. Now, two matrix are equal. See, two matrices are equal if first point they are of same order. Second, they are of same order. Second, their corresponding entries are same. They are of same order and their corresponding entries are same. That means a matrix of order 2 by 3 can never be equal to a matrix of order 3 by 3. So first of all, order should be same. Like if I say a matrix A, B, C, P, Q, R is equals to X, Y, Z, L, M, N. So that means what? That means A equals to X, B equals to Y, C equals to Z, and P equals to L, Q equals to M, and R equals to N. So two matrices will be equal only if their order is same and their all corresponding entries are same. Like if I ask you a simple question, matrix sin square theta cos square theta 1 tan theta. This is equals to 1 by 2, 1 by 2, 1, 1. So find theta for which this situation holds. Find theta for which this situation holds. Yes, anybody? I just saw somebody answered 45. See, now you are a grown-up child. You have grown up now. So just answering 45 won't be sufficient. Anybody, any other answer? One, no, Sanjana. Now see, what do you want? You want sine square theta as 1 by 2 as well as cos square theta as 1 by 2 as well as tan theta as 1. Yes or no? So with this tan theta as 1, you will say that your answer will be in first and third quadrant. Yes, from here you can say sine theta is plus minus 1 by root 2 and cos theta is also plus minus 1 by root 2. So see, seeing all the situations, sine theta plus minus 1 by root 2 in 0 to 2 pi, you will say it is pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Similarly, cos theta plus minus 1 by root 2, pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Everything is working. But tan theta will lie in first and third quadrant only. So you will say it is pi by 4 and 5 pi by 4. Yes, that's not correct. Sine minus 45 is not the answer. So if you want to generalize it, what is theta? Theta is n pi plus pi by 4, where n belongs to some integer. Theta is n pi plus pi by 4. Got it? So this is how we manage with the equality in matrices. Now there comes next topic. Anybody having any doubt till now? Now there we comes algebra of matrices में equality done. Now we have addition of matrices. Addition or subtraction of matrices. Again, when can we do this? Again, same thing है. Two matrices can be added or subtracted if, first point, they are of same order. Second point, first of all, they are of same order. Second point, resultant will be and resultant will be the addition or subtraction of two matrices. This is addition or subtraction of the corresponding entries. Corresponding entries of two matrices. Am I clear? Like if there is a matrix A, B, C, D, E, F, and you want to add it to P, Q, R, X, Y, Z. So what it will be, first of all, you will check, are they of same order? Yes. Now when they are of same order, it will be A plus P, B plus Q, C plus R, D plus X, E plus Y, F plus Z. And if you subtract them, their corresponding entries gets subtracted. Am I clear? So this is how we do addition or subtraction of matrices. Is it fine, everybody? Now, like a simple, one or two more simple properties about it. Matrix addition is commutative. Commutative means A plus B is B plus A. Second, addition is associative. That is A plus B plus C is A plus B plus C. So that won't make any difference. Got it? Then there comes another term like A plus B is a null matrix is also B plus A. That means what? A and B are called additive inverse of each other. A and B are called additive inverse of each other. Got it? Any doubt? Akshay understood? Let's move forward. One more last thing we'll do before we proceed with few questions over it. That is multiplication of matrices. Multiplication of matrix by a scalar. Now scalar is nothing but a number like 2, 3, 5. Got it? So if you say a matrix is A, B, C, D, and you multiply this matrix by some number K, that means every entry of A will be multiplied by the same number. All right, I'll hold the screen so that you complete your notes. So multiplication of matrix by a scalar is nothing but simply multiply each entry of the matrix by the same scalar. Understood? Now, let's do some questions. See, the first question I have for you is, Hello. I'm so sorry, everybody. Actually, power went down. All right. So I think I'm audible to you. Am I audible? Yeah. So I think I'm audible to you now. Let's do a question. Question is, A is given as 2, 3, 4, 5, 7, -1, and B is -2, 0, 1, 4, -1, 3. Find the matrix 2A plus 3B. Yes, quickly give me the answer. Very easy question. Quickly tell me the answer.
So it's -2.
Sorry.
-2, 6,
-2, then
6,
6,
5,
5,
22,
22,
11,
11.
7.
Very good. Thanush also very good. -2, 6. He's saying 11 at the A31, A13 position. 4 to the 8 and 3. Yes, it's not 5. It is 11. Anybody who got any other answer? All right. So write down next question. Let 2x plus 3y is 1, 2, -1, 0. And 2x minus 5y is -3, 4, 0, -2. Find the matrices X and Y. Find the matrices X and Y. Yes, quickly go for it. Give me the correct answer. You got 2 minutes. Yes. Anybody? See, to get Y, you can directly subtract these two matrices. Subtract the two equations. So if you subtract them, see 2x will cancel out. But you get 3y plus 5y. Left side you get 8y. Right side you subtract these two matrices. So it is 1 minus minus 3, subtraction of corresponding entries. 2 minus 4, minus 1 minus 0, 0 minus minus 2. So it came like 4 minus 2 minus 1, and this will be 2. All right. What did I do? Okay, J, N, V, K. I'll explain again. See, what you need to do, I just subtracted the two equations. So if you subtract these two, means this minus this plus this minus. So these terms will cancel out. So what do you get? 3y plus 5y. It will become 8y is equals to 1 plus 3, 4. 2 minus 4 minus 2 minus 1 minus 0 minus 1. 0 minus minus 2 is 2. So in this way, your y will be 4 by 8 minus 2 by 8 2 by 8. So this became minus 1 by 4 minus 1 by 8 and 1 by 4. This is your y. Got it? Now to get x, one way is you put this value of y here in any of the equations. Other way is you multiply the two equations in such a way that y cancel out. So what do I do? First equation multiply by 5. So if you multiply by 5, you get 10x plus 15y. 10x plus 15y is equals to, multiplied first equation by 5. 5, 10 minus 5, 0. 5, 10 minus 5, 0. Now multiply second equation by 3. By 3 means 6x minus 15y is equals to, multiplying by 3 is minus 9, 4 3s are 12, 0 and minus 6. Yes or no? Now what is the best way to get x? Add both the equations. So now add both of them. So what do you get? 16x is equals to 5 minus 9 minus 4, 10 and 12, 22, minus 5 minus 6. So x is what? Minus 1 by 4, 22 by 16, minus 5 by 16 minus 6 by 16. So this is your answer. Understood? Anybody facing any issue? Please respond. Anybody having any other doubt, any problem? Okay. So now one question I leave for you. I want the correct answer from all of you. The question is, why we have to multiply with 5 and 3? See, unless you don't multiply with 5 and 3, how will I cancel it? To get x, you have to cancel y. To cancel y, these two coefficients should be same. Like we have done in pair of linear equation in two variables in the 10th class. Yes or no? So that is why I multiplied this equation with 5 and multiplied this equation with 3. So that it becomes 15, it became 15 and they are cancelled. Now one question for you. Let a plus 2b is equals to 1, 2, 0, 6 minus 3, 3, minus 5, 3, 1. And 2a minus b is equals to 2 minus 1, 5, 2 minus 1, 6, 0, 1, 2. Then find the value of trace of a minus trace of b. Yes, trace of a minus trace of b. Trace, I have told you in the beginning of the class, it is the sum of the diagonal entries. See, trace is what? A11, A22, A33 are called diagonal entries. And sum of the diagonal entries is called trace of the matrix. Trace is what? Sum of the diagonal entries. Now quickly do trace of A minus trace of B. Two. Okay, how did you get two? Two is answered by Dhanush. Dhanush, how did you get two? Siri got minus 4. Siri, any explanation you have? Minus 4 is not the correct answer. Anybody else? Dhanush, how did you get two? Now see. While we see A plus 2B, can I say that trace of A plus 2B is 1 minus 3 plus 1, that is minus 1. That means trace of A plus 2 times trace of B is minus 1. Got it? Now see the second equation. Trace of 2A minus B is what? 3. That means 2 times trace of A minus trace of B. This is 3. Now you have these two equations. So from these two equations, you will be finding trace of A and trace of B, which is like simple linear equations, and then add or subtract them. All right. Like trace of B is the trace of A plus 2 times 2 trace of A minus 3 is equals to minus 1. So 5 times trace of A is 5. That means trace of A is 1. You put it anywhere, trace of B comes minus 1. And if you subtract them, trace of A minus trace of B will be 2. This is going to be your answer. All right. So that would be all from my side for today. Just revise today's notes. So in the next class, we shall be starting with product of two matrices, which is quite tough and important also. All right. So just before ending the class, let's have a small session for the feedback. Please. Over to you. Mark your feedback. All right. Sir, can't we do this question as we did previous? Yes, we can do by that method also, but that will be very lengthy. Why to extend the length of the question while there are shortcut methods? We are not required to find the we are not required to find the question matrices. We just need this trace.